This is problem number 27 from Hall and Knight Higher Algebra, Chapter 1 Ratios. We have been given three equations: a times y plus z is equal to x, b times z plus x is equal to y, and c times x plus y is equal to z. We are given that if these equations are true, we have to prove that x square over 1 minus x square over a times 1 minus bc will be equal to y square over b multiplied by 1 minus ca, and so on. So I have just rewritten these three equations so that we have zeros on the right hand side and we have coefficients of x, y and z on one side. So from equation number 1 and 2, by the rule of cross multiplication, what we get is x over minus a times b is minus ab minus plus a minus a y over minus ab minus b is equal to z over minus 1 minus minus ab will be plus ab. So let us multiply each of these equations by minus 1. So we will get x over a plus ab y over b plus ab z over 1 minus ab. So this is the relationship that we get from 1 and 2. Let us call this relationship as K1. Okay, we are assuming that each of these ratios is equal to some constant K1. So from 2 and 3, we get x over 1 minus, this is 1, minus bc is equal to y over bc minus b. So we get bc plus b is equal to z over bc minus c is plus c, and we will call this relationship as K2. Okay. Similarly, from 3 and 1, we will get x over a plus ab, a plus c times a plus ca, okay, is equal to y over over, we have minus a here, minus AC, minus AC, minus 1, so that will be plus 1, 1 minus AC, so we'll write it as 1 minus CA is equal to Z over C minus AC, so C plus CA is equal to K3. So now we know that x over 1 minus BC is over here, which is also over here. So let us multiply K2, and K1. If we multiply K2 and K1, what we get is K1 is x, K1 K2, K1 is x A plus AB, which we can write as A times 1 plus B. Okay, this is K1, and we multiply x over 1 minus BC. This is K1 K2. This is also equal to y or let us say z. Okay, we are taking z because we want 1 minus AB. 1 minus AB, and what is K2 here? K2 is z over C times, you take C out and get B plus 1. So what we see is that this B plus 1 and this B plus 1 can cancel each other, assuming that B is not equal to minus 1. So I am not going to, I hope you already know that whenever you are dividing or cancelling like this, you always tacitly assume that this term is not going to be 0. Division by 0 is not allowed. Okay, so now we get x square by A 1 minus BC is equal to z square by C 1 minus AB. So using K1 K2, we have proven that this expression is equal to this expression. Similarly, if you multiply K2 K3 from K2 K3 by symmetry, you will be able to prove that this will be equal to y square by B 1 minus CA. So we multiply K1 K2 and we get the relationship between x square, this and this. If you multiply K2 K3, you will get the relationship between this and this, and because this term is equal to this term is also equal to this term, so all these three terms must be equal, and we are done.